Hi everyone, today we'll be doing Winter 17 paper 1-3, so pure mathematics. Let's get on with the video. An arithmetic progression has the first term -12 and the common difference of 6. The sum of the first n terms exceeds 3000. Calculate the least possible value of n. So first you have -12 for A and 6 for D. Now in order to get the sum of n, your equation will be n over 2 multiplied by -24 because 2a plus n minus 1 multiplied by 6. This exceeds 3000. So you will have -24n divided by 2 plus 6n squared minus 6n divided by 2 exceeding 3000. If you simplify your equation, you will eventually get n squared minus 5n minus 1000 exceeding 0. So your n will be 5 plus minus 5 squared minus 4 multiplied by -1000 divided by 2. So you will either get 34.2 or 29.2, but a progression cannot be a negative number. So your number n must be 35 and above. Notice how I don't use 34 because 34 is still below 3000. Find the set of values of A for which the curve shown and the straight line shown meet at two distinct points. So if they meet at two distinct points, you can just first equate them with each other. Is equal to ax plus 3a. I will multiply everything by x, so -2 is equal to ax squared plus 3ax. And for meeting at two distinct points, your discriminant, which is b squared minus 4ac, must be larger than 0. So 3a squared minus 4, 2a is larger than 0. You have 9a squared minus 8a is larger than 0. And if you factorize a out, you have 9a minus 8 is larger than 0. So your values are a is larger than 8 over 9 or a is smaller than 0. This can't be a larger than 0 because if a is larger than 0, then your points will not meet at two distinct points. Find the term independent of x in the expansion of shown. So if it's independent of x, your value will not have an x component. So if I want to cancel this and this together, it will be 1 over x cubed multiplied by x cubed itself. Using that thought in mind, it will be 63 2 over x cubed -3x cubed. So your value is -4320. Find the value of a for which there is no term independent of x in the expansion of shown. So first what you need to know is that ax squared means that you have to cancel out the x squared eventually. So you need 1 over x squared from here. And to get 1 over x squared, you have 62 multiplied by 2x to the power of 4, 3x to the power of 2. So this way you will have 16 over x for this value and 9x squared for this value. So you can just cancel out the powers and this will be square, which is what we need. So from here, your value is 2160 x squared. Now you can multiply 2160 and a. Instead of x squared, I should have written divided by x squared. So when you multiply these together, your x component will cancel out. So 2160 multiplied by a minus 4320 is equal to 0 because there's no term independent. So 2160a is equal to 4320 and a is 2. The function f is such that the function is equal to 2x minus 1 to the power of 1.5 minus 6x, for half is smaller than x is smaller than k, where k is a constant. Find the largest value of k for which f is a decreasing function. So if you want to know if a function is decreasing or increasing, you first need to find the derivative. So dy over dx is equal to 3, 2x minus 1 half. I get 3 from 3 over 2 multiplied by 2 minus 6. So you want this as a decreasing function. So 3, 2x minus 1 to the power of 0.5 minus 6 is smaller than 0. Now 2x minus 1 to the power of 0.5 is equal to 6 over 3. And I will multiply this, I will square this to cancel out the half, the power half. So 2x minus 1 is smaller than 2 squared. So 2x is smaller than 4 plus 1, and x is smaller than 5 over 2. Since this sign satisfies your question, so your value k is equal to 5 over 2. Show that the equation cosine theta plus 4 divided by sine theta plus 1 plus 5 sine theta minus 5 is equal to 0 may be expressed as 5 cos squared minus cos minus 4. First, what I want to do is to make everything on the left-hand side of the equation into a fraction. So I can just write cos theta plus 4 plus 5 sine theta multiplied by sine theta plus 1 minus 5 multiplied by sine theta plus 1 divided by sine theta plus 1 is equal to 0. Now I will multiply everything with sine plus 1. That will give me cosine theta plus 4 plus 5 sine squared theta minus 5 is equal to 0. Now I will change sine squared theta into 1 minus cosine squared theta because sine squared plus cosine squared is equal to 1. So cosine plus 4 plus 5 in parentheses 1 minus c squared minus 5 is equal to 0. And my final equation will be 5c squared minus c minus 4 equal to 0, which is that equation shown in the question. Now I will change this left-hand side equation into the equation I just got earlier. So 5c squared minus c minus 4 is equal to 0. And I will find theta by using the negative b plus minus the square of b squared minus 4ac divide by 2a, which is 2 multiplied by 5. This will give me 1 plus minus 9 divided by 10. So it will either be 1 or negative 0.8. Now cosine theta is equal to 1 and cosine theta is equal to negative 0.8. For this, your theta will be 0, and for this, your theta will be 143.1. Now, since this cosine function is positive, so you get two other values. So 360 minus 0 is 360, and 360 minus 143.1 is 216.9. So these four are your values. Find an expression for the inverse of the function f. So to find an inverse, you just substitute the x there with a y first. So y squared minus 1 is equal to x. Now you will make y the subject of the formula again. So y squared is equal to 2 over x plus 1. And I will square root everything to remove the square. So y is equal to plus minus 2 over x plus 1. Now since x must be smaller than negative 1, you know that the range for the inverse is a negative 2 over x plus 1. This is because the domain of the function f is equal to the range of the inverse of that function. So similar to this domain, your range for y should be a negative number. Thus, we use negative instead of the positive sign. Solve the equation gf is equal to 5. So we will input the function f into the function g. So 2 over x squared minus 1 square plus 1 is equal to 5. 4 divided by x to the power of 4, 2x squared plus 1 is equal to 4. So you will get x to the power of 4 minus 2x squared is equal to 0, and factorize x squared out. So x squared 2 is equal to 0. So your values are x squared is equal to 0 or x squared is equal to 2. Since your x is a negative for the domain of the function f, so instead of having positive and negative 2, you only need negative. And since the domain doesn't mention 0, it should be lesser than a negative number. 0 is not an answer as well. Show that angle ABP is 0.6435 radians, correct to 4 decimal places. Notice that AB, BP, and PC, this is parallel to each other, so the angle here should be the angle here. Now you can find first angle ABD by sine theta is equal to 3 over 5. So theta is equal to the inverse of sine 3 over 5, and this will give you 0.6435 radians. And angle ABD is equal to angle ABP, so they're both 0.6435. Calculate the areas of the sectors BAP and DAQ. So first I want to find the area of the sector BAP. So sector BAP has an angle 0.6435, the one we got earlier, and the radius is 5. So using the formula 0.5 multiplied by theta multiplied by r squared, we have half multiplied by 5 squared multiplied by 0.6435. This will give us 8.04 unit square. Now for the area of sector DAQ, we have 90 degrees here, and our radius is 3, so half multiplied by 3 square multiplied by pi over 2, which is 90 degrees, and this will give us 7.07 units square. Calculate the area of the shaded region. Now in this diagram, we know that there is a sector BAP, which was mentioned earlier, and if we see the new shape here, it will make a trapezium. So we know that the height is 3, but we do not know what PD is, the length of PD. So what we need to do is to find the length of PC by the use of the Pythagoras theorem. We know that BP is 5 and 3, so PC should be 4. And we'll calculate the area of the trapezium and subtract the area of BAP from that trapezium to get this small section. Now I mentioned that the length of PC should be equal to 5 square minus 3 square. This is equal to 4. So your trapezium, the area of your trapezium is equal to half multiplied by 5, which is the first length, plus the length we got earlier, but minus, subtract 4 from 5, so 5 minus 4 to get the small length dp, and multiply this with the height, which is 3, and you will get 9. So the area of the trapezium minus the area of ABP should be equal to 9 minus 8.04. So this is equal to 0.96 units square. Next, we see that there is a sector DAQ, and that the small section DAP here is not the shaded area, so we need this one. So we can just subtract the small section here from the area of the sector DAQ. We found sector DAQ already from the sub-question earlier. So DAQ minus 0.96 is 7.07 minus 0.96, which is equal to 6.11 units square. Find by calculation the x-coordinates of A and B. We know that A and B are the points of intersection, so we can just equate the graphs with each other. So 3 minus 2x is equal to 4 minus 3x and half. And your equation will be 3x half minus 2x minus 1 is equal to 0. Now I'm going to let u be 6 to the power of half. So 3u minus 2u squared minus 1 is equal to 0. And your roots are 2u plus 1, u minus 1 is equal to 0. So I will revert u back to x to the power of 0.5. So the square root of x is equal to half, and the square root of x is equal to 1. So x is equal to 1 over 4, and x is equal to 1. Find, showing all necessary working, the area of the shaded region. Now the area of the shaded region is the area of the line minus the area under the curve. So we will first find the area under the line. This will be 1 over 4 and this will be 1 since we found that as the points of intersection. So 3 minus 2x dx is equal to 3x minus x squared to the power and 1 over 4. So your value will be 3 minus 1 minus 3 over 4 minus 1 over 16, which will give you 1.3125 units square. Now for the area under the curve, this will be 1 and 1/4 2. Your equation will be 4 minus 3x to the power of half dx. So 4x minus 2x to the power of 3 over 2, 1 and 1 over 4. So 4 minus 2 minus 1 over 4. This is equal to 1.25 u squared. So the area of the shaded will be area under the line minus the area under the curve, which is 0.0625 units square. To find the magnitudes of these three, we will need the vector first. So AB. So AB is OB minus OA. So -10, 3, -13, minus 8, -6, and 5. So this will be -18, 9, -18. So the magnitude will be the square root of the numbers by square, which will give you 27. For BC, it's OC minus OB. So 2, -3, -1 minus -10, 3, and -13 will give you 12, -6, and 12. So your magnitude will be the square root of 12 squared plus 6 squared plus 12 squared, which will give you 18. Since this is a geometric progression, your R is 18 over 27. So you can just calculate the magnitude of CD by 18 over 27, multiplying that with 18. So the magnitude is 12. Given that D is a point lying on the line through B and C, find the two possible position vectors of the point D. So assume that the line BC looks like this. This is not the real representation. And assume that D is located here, or D can be located there. So you have to find the vector CD, 18 over 27, and 12, -6, and 12, which is BC. This will equal to 8, -4, 8. So CD is equal to OD minus OC, and OD is equal to CD plus OC. But since there are two values, it can either be here or here. You can also minus 2, -3, -1. So your values are 10, -7, 7, or negative 6, 1, 9. Our curve has equation y is equal to function, the function, and it is given that the inverse of the function is ax squared plus bx, where a and b are positive constants. Find in terms of a and b the non-zero value of x for which the curve has a stationary point, and determine, showing all necessary working, the nature of the stationary point. So if there is a stationary point, ax squared plus bx should be equal to 0. So factorize the x out, and ax plus b is equal to 0. So x is either equal to 0 or x is equal to negative b over a. Now to find the nature of the stationary point, you have to find the second derivative. So the second derivative is 2ax plus b. Since we're looking for the non-zero value, we will use this value. So when x is equal to negative b over a, the second derivative is negative b. So since this is a negative value, it will be a maximum point. It is now given that the curve has a stationary point at negative 2 and negative 3, and that the gradient of the curve at x equals to 1 is 9. So find the function. Again, we have stationary point, so we will use the x value, which is negative 2, to the derivative. So a negative 2 squared plus b negative 2. This will equal to 4a minus 2b is equal to 0. The other one, the gradient of the curve is x equals to 1, so we can just use the value 1, is equal to a plus b is equal to 9. So we'll use these two values to perform the elimination or substitution methods. I will multiply this by 2, so I will use elimination. 4a minus 2b is equal to 0, and 2a plus 2b is equal to 18. So add these together. 6a is equal to 18, and a is equal to 3. Now input a as 3, so 3 plus b is equal to 9. So your b is 6. Now integrate the values. So the integration of 3x squared plus 6x dx is x cubed plus 3x squared plus c. So we will use the point negative 2, negative 3. So negative 3 as y is equal to negative 2 cubed plus 3 negative 2 squared plus c. So your c is negative 7. So your equation is x cubed plus 3x squared minus 7. If we want to find the equation of the line, we will first need the gradients. So the gradient of AB is equal to y2 minus y1 divided by x2 minus x1, which is equal to half. So your equation will be y minus 0, we'll take a as the point, is equal to half x minus 1. So simplify that to y is equal to x over 2 minus 1 over 2. Find, showing all necessary working, the equation of the tangent to the curve which is parallel to AB. So the equation of the tangent should be the derivative. So half x minus 1, negative half. This is equal to half as well, because the parallel to AB means having the same gradient as AB. So half is equal to the equation above. And you will get x minus 1 half is equal to 1, and x minus 1 is equal to 1, so x is equal to 2. When x is equal to 2, your y is equal to 2 minus 1 half. This is equal to 1. So your equation will be y minus 1 is equal to half x minus 2. So y is equal to x over 2. Find the perpendicular distance between the line AB and the tangent parallel to AB. Give your answer corrected to decimal places. So assume that this is your line and this is your tangent and this is your line, and you need to find the distance here. So the distance should be the gradient of AB multiplied the gradient of the perpendicular line should be -1. So the equation of the the perpendicular line is -2. So in order to find the equation of the perpendicular line, we can just use the point here, which is 2 and 1. So if 2 and 1 is used, your equation will be y minus 1 is equal to -2x minus 2. So y is equal to -2x plus 5. When it intersects the line AB, -2x plus 5 should be equal to the equation of line AB, x over 2 minus half. So x will be 11 over 5. And when x is 11 over 5, your y should be -2, 11 over 5 plus 5. This is equal to 3 over 5. So this is 11 over 5 and 3/5. Now you can just find the distance of this perpendicular distance by using the equation. D is equal to the square root of y2 minus y1 square plus x2 minus x1 square. So this will be equal to the square root of 0.2, which is 0.4472 or 0.45 units. Don't forget to hit like and subscribe. See you next time.